Alright, remember, a week from today is the last day.
And then any AP class,
The last day for math week,
that way the folder is like,
so don't forget to get that. Figure it out.
the last year we were trying to take the
Alright, let's see.
She's still out.
You know how she's doing? She's doing okay. She never listened. She listened to it. All right, so okay, let's get our notes out. We're gonna pick up where we left off.
Are you live?
Okay. According to my records, we are in P2. Ready for number 4?
Yeah.
What?
What is that for? Oh yeah, yeah. One last one.
Okay. So number 4 has some maybe new notation to you. We got point A, point B. These are points in the Cartesian coordinate plane. And we are going to find this. Now notice, it doesn't have any, it's just a plain A and B. There's nothing over it, around it. It's just a plain A and B. Does anyone know what that means? Erica? What? Okay, I couldn't hear you. I got it. Where they intersect? Well, they are two separate points, so they wouldn't really be intersected. We will later on be doing where lines intersect, but this is two individual points. Ben? What? Okay, he says it's a line. It has something to do with that. This actually means the distance from A to B. So this is going to be a number, just a single number. It isn't going to be the equation of a line. That is, I think, P3. We're going to do equations of lines. But right now, we're just going to find out how far is it from that point to that point. Now, what pops into your head when you see the word distance?
Distance formula.
The distance formula. Okay, so he knows there's a formula. Can't remember what it is. Does anybody remember what it is? I'll give you a hint. It's got a big radical in it. Okay, so I won't tell Hollis and Weddington about this. You should know this. So the distance formula says you take your x coordinates, subtract them and square them. Take your y coordinates, subtract them and square them, add them together and take the square root. Does that look familiar now? So in your ordered pair, it does not matter who's x2 and who's x1. It doesn't matter. Truly, it doesn't matter. Do not waste a minute worrying about that. Just one of them is x2, y2, and one of them is x1, y1. So what does my formula say? 4 minus 3 squared, negative 1 minus 2 squared. So what am I going to end up with? Is that 1? I I made 2 mistakes last period, so keep an eye on me today. That's 1. And this is going to be 9.
Yeah.
So the answer is the square root of 10. Remember when I told you it's just going to be a number? It's just a number. It's not an equation. It's not slope and all that stuff. It's just a distance. Would you now, you and your partner, try B, problem B? You're going to do exactly the same thing.
This is 4.
Uh-huh.
On this one, is there a reason the square root doesn't cancel out the exponent?
It's a plus sign.
Oh.
So Michael's question is this. He says, I know that square rooting and squaring are inverse operations, so they should cancel each other out. Not when you introduce a plus sign. So here's the best example I can think of. What's 3 squared? 9. And 4 squared is 16. And that makes 25. And the square root of 25 is 5. But if we just cancel out the squares, it's like, so as soon as you put a plus sign in the
Square root.
I know, but I was asking to break it down.
What?
Do you break it down or do you leave it?
You can't break it down, it's just a number.
all right,
Would you do like 8, like 2, and like 7 or something in it?
Yeah, I tried that.
Oh, you already tried it?
You're good.
You're good. What are you, you're gonna end up C on that.
Did you get the square root of 82? No?
I did.
Yeah.
Yeah, that's what I got.
Now notice, I did this minus this. Most of you probably did this minus this. It makes no difference because since you're squaring it, mine came out negative, the square is positive, so it doesn't matter. Again, x minus x, y minus y, subtract and square and add up to 3. Okay? All right. Pretty good? Okay, now we got midpoint. So we have 2 points, 3, 7, negative 2, 11, and we're going to find the midpoint. So obviously you can visualize this. Here's a point, here's a point. There's a point right in the middle of those 2, and I need to figure out what it is. So what is your thought? What do you remember about midpoint?
Midpoint formula.
There is a formula for midpoint. Absolutely. And you're welcome to use it, but I want you to just think about something for a minute. Midpoint is the middle point, right? Middle point. And the middle value is the average. Midpoint is just average. How do you average things?
Add both and then subtract by how many you get.
Add them
And then-
and
or
divide
divide,
by how many you got.
Uh-huh.
So since there's 2 x's, I'm gonna add them and divide by 2.
2.
So
1 divided by
add them and divide by 2 would be 1/2. So that's 3 plus negative 2 over 2. That's the math I'm doing. Midpoint is average. Midpoint is average. We're gonna be doing a lot of that throughout, like chapter 4, all the trade graphing. We're gonna be finding the middle. Average, average, average. So what's my average y? 9. 7 plus 11 divided by 2. Now, those of you that love your formulas, here you go.
It's just the same thing.
No, exactly. No one is ever going to ask you for the formulas. You just have to know how to use them. So if you can remember midpoint is average, okay, that's one less thing you have to memorize. Midpoint is average. Add and divide by 2. So with your partner, do the second one. Do B.
B.
All right, what did you get? When you added your x's and divided by 2, I hope you got 1.
Yes, it is.
And when you added your y's and divided by 2, I hope you got 2. So 1 comma 2 is your number. All right. Find the area and perimeter of the figure form. So I have plotted my points. And I am going to start by finding my perimeter. Now, what does perimeter mean? Add up all the sides, right? So if I want to know what the perimeter of this thing is, I have to know how long each side is. So in other words, I have to know AB. This length right here. So how am I going to do that? It's distance. We just talked about it. We're going to find the distance. So on your own, right now, keep working. You're going to find AB, BC, and AC. We need all 3 of them. We're going to do perimeter. So go ahead and start doing your distance formula.
Whose word is now? And this is negative. Yeah, because
I did it all wrong.
Yeah, I heard somebody say I did it all wrong. This is not a good thing. We need to be able to do our distance.
So I'm a little bit concerned.
So where are we confused?
No, I just,
You square both.
I just picked the wrong numbers. It was just a mistake.
You gotta figure out them.
Yeah, I know.
You square both inside up.
So you do the subtraction.
You do it first.
Yes.
Exactly. So we're trying to
And
like figure out
this
which
is
one
first. So we're gonna subtract this and then square it. So you're subtracting first. So subtract your x's and square it.
Yeah, I did like that.
Subtract your y's and square it. And then add those together. Now, like I said, I'm very mistake prone today. How do those look? Anybody got those? Those look good? So,
I actually really like that.
now is the time to ask a question, folks. This is what I get paid for, answering your questions. So who doesn't follow to this point? Good to hear?
Yes.
Okay. So now, I need perimeter, that was my objective. So I'm gonna add all these up. So root 41, root 41, root 82. Now, who remembers how we add radicals? Okay? Remember, the only calculator allowed in this class is your grapher. So you're not gonna have your little cheated calculator that does the radicals for you. You're gonna have to know how to add these together. So what's root 41 plus root 41? 2 root 41, yep. And can I add the root 82? Nope. radicals, they have to have the same, what we call radical. This number has to be the same. So these two will add, it's like an x and an x, makes 2x, but then you got like a y here, you can't add that. So that's your formula. Now this problem is sneaky, because they also want you to find area. What kind of shape is it? Triangle. And how do we find the area of a triangle? 1/2 base times height. And if we're going to do 1/2 base times height, that means there has to be a right angle in here somewhere, based on the height come together. You can kind of eyeball it probably and see, but there's a mathematical reason that that right there is the right angle. This is root 41, this is root 41, and this is root 82. I want you to look at something. Root 41 squared plus root 41 squared equals root 82 squared. Would you agree with that statement? And if a squared plus b squared equals c squared, you have a right triangle. This is tricky, okay? This is tricky. Stay with me. So now I know that's a right triangle. And now I can find my area. My area will be 1/2. Here's the right angle. So these are the base and height. That's the hypotenuse. These are the base and height. So root 41 times root 41. Alright, here we go. No calculator needed. What's root 41 times root 41? You're multiplying. Root 31 times root 41 is
41.
Oh, it's 1 times 1.
what's the square root of 5 times the square root of 5? Not 1.
I'm so
They don't even
lost.
break it. Root 5 times root 5 is
5.
5. Because when you multiply a radical times itself, the radical goes away. So what's root 3 times root 3?
3.
What's root 10 times root 10?
10.
10. What's root 41 times root
41?
41? Oh, we got the hang of it
We'll
now.
start.
So 1/2 times 41, 41 halves. I know it's really hard to stay tuned in here with this environment, but we have to. All right, are you ready to tackle the next one? First thing I want you to do is plot those points. You need to get a feeling for where those points are. So let's plot them. You got these guys plotted? Things worked out kind of nice.
It's 4 right.
What kind of shape is this?
It's 4.
I don't know if it's a square or not, because I don't know how long the sides are yet, but it's certainly a rectangle. Would you agree that these are all right angles?
Yes. Yeah.
I won.
And we don't even really need the distance formula. You can use it if you want. But since these are right straight across from each other, I mean, imagine you have graph paper. Couldn't you just count?
Yeah.
And so from -2 to 4 is 6. So these are 6s. And from 1 to 7 6 is 5. So it's not a square, but it certainly is a rectangle. And the perimeter is easy. 22. And the area is easy. How do you find the area of a rectangle?
35.
Length times width, base times height. So 6 times 5 or 30. That one was way easier.
Do we need like a label on there or anything?
No, because these are just tools. If I knew these were, let's say, an inch apart, then this would be 22 inches.
An inch is square.
Alrighty. Now I'm gonna challenge you. This is easy. That was easy. Now we've got another figure.
No, I'm fine.
So let's go ahead and plot these points.
Royce, look at C. What's point C?
Yeah, point C is 6 comma 7. So it ended up behind my board there. But you're plotting it yourself, so you know where that's at. So I ended up with a very skinny, long, quadrilateral, could be a parallelogram, I don't know, kind of looks a little parallelogram-ish, but I don't know that. So I'll give you a minute, get those plotted. And now your job is to prove that the diagonals bisect each other. Okay, so what are the diagonals? Yeah. So AC
So 6, 7 actually.
and PE are the diagonals. What could my strategy be to prove that they bisect each other?
We find the midpoint of both,
And what's going to happen, hopefully?
whether it's the
Exact
same.
same.
So we're going to find the midpoint of each segment. So the midpoint of my blue segment, which is AC. How do I find midpoint again?
X1.
Average. Add them up, divide by 2. So -2 plus 6 divided by 2. -3 plus 7 divided by 2. Okay. Now I'm going to find the midpoint of BB. 0 plus 4 divided by 2. And 1 plus 3 divided by 2. And there you go. There you go. I thought that was going to be a big, huge challenge, but you people are brilliant, so that's easy enough, right? If the midpoints had not turned out to be the same, then they wouldn't bisect each other. The fact that they do means we have a parallelogram. This is a parallelogram. Remember that horrible chapter from geometry where you had to learn all the properties of rhombuses and heights and all that. I'm just saying that. Okay, problem 8. Write the equation of a circle. Does anybody know what the equation of a circle looks And the, circumference of a circle
It's too high.
Finish.
is 2 pi r. But that's not what I'm asking you for. I'm asking you for the equation of the circle. So I'll just give you an example. This is an example of the equation of a circle. So, a circle equation has something squared plus something squared equal to a number. Now, the center of this circle is the point 4, negative 3. So where'd that come from? 4, negative 3 is the opposite of these. And the radius of our circle is 5. Where did that come from? This is r squared, radius squared. So that's what a circle looks like. If I had this circle, the center would be at 4, negative 3, and the radius would be 5. So, could you work that backwards for problem 8a? Could you tell me what the equation of the circle would be?
Is it?
If the center is 0, 0, then what am I gonna have here? X minus 0, y minus 0. And if the radius is 3, what am I gonna have here? 9. That's it, it's that easy. Circles are our favorites, they're so easy. Okay, tell me what B is. Center of X minus 5 squared, don't forget the squared, plus y, y plus 4. We're on problem B. So X minus 5, y plus 4, and equals 36. Perfect. Last one, X minus 0 squared plus y minus 4 squared equals, there we go, we learned something today. The square root of 5 squared is number 9. What's the center? 9a. The center is
2,
2,
negative
negative
3.
3. And the radius is 4. B. Center is negative 5, comma, 0. And the radius is square root of 7. C. Center is
0,
0, 0. Radius is square root of 10. Square root of 10. Okay, how we doing? So far, so good? All right, write using absolute value. Now this is probably new to you. I don't think you guys did this last year. So let me just back up a second. If I drew, this isn't in the notes, just look up here for a second. If I said to you, what is the distance between those 2 points? You would all say 2. And you got that by doing what? Subtracting. Now, you did 7 minus 5. You could also have done 5 minus 7 if you put it in absolute value. Those are the same thing. So the distance is simply the absolute value of the difference. In other words, subtract and take the absolute value. Okay, so this is the distance between 7 and 5. it says the distance between x and 3. Well, if this is the distance between 7 and 5, then won't this be the distance between x and 3? And the distance between x and 3 is 8. There you go. That's all there is to it. Distance is the absolute value of the difference. So you're going to subtract and take absolute value. So what does B look like?
X.
Absolute value x plus 2
Plus 2.
is greater than 7.
Absolutely. I don't know who said that, but you were right on
You're right.
target. That's it. Why is that a plus?
Because there's so many.
Because it's minus a negative. Distance is always a subtraction. If you're subtracting a negative, it's going to become positive. Okay, what about C?
Absolute value is 4 plus X.
Be careful. It's always a subtraction.
4 minus X equals 12.
Yep. Now, could you have done this? I'm kind of anal about having my x's first. So could I have written it this way? Are they the same thing? Guys, are they the
No.
same thing?
Or yes.
Yes. As long as you're taking the absolute value, they're the same thing. It's a difference. A difference. All right. D, last one. What's that one gonna look like? The distance between x and 5, x minus 5,
Is less than or equal
no
to
more than 3,
3. Less than or equal to 3.
less than or equal to 3. Yeah,
Can I go shoot?
is it an emergency?
No.
Okay. We'll wait 20
Okay.
minutes. All right, write the equation of the circle whose diameter, oh my goodness, wait a second. Okay, I need some help here. I've got a circle and 3, -6, and 4, 0 are the endpoints of diameter. Now, I did not plot these 2 points because their relationship to each other isn't important. But if that bothers you, go ahead, set up a grid and plot those 2 points. Okay, it doesn't matter. You don't have to plot that this time, but you certainly can if you want to. Now, I'm gonna write the equation of that circle. So I know that it looks like this. If you're not sure about that, look back a couple of problems when we were looking at circles. This is what they look like. Now, if I'm gonna fill in the blanks, where do I need to go? Center? Now, this is the diameter. What do you know about the center? Isn't it
The
the
radius.
midpoint of the diameter? Do we know how to find midpoint?
Yeah.
Yeah, we'll average. So 3 and 4 makes 7 divided by 2. Either 7/2 or 3.5, it makes no difference, do whatever you want. So 3 plus 4 divided by 2, all right. And then -6 plus 0 divided by 2, -3. So far, so good? Now, that is the center of the circle. So doesn't that go in here? So x minus, I'm using 7/2, use 3.5, no difference, I don't know. And then y, watch it, plus 3. Okay? Now I need this number. Where does that come from? How do I, what what's your radius squared? Remember, this is r squared. So how am I gonna find my radius?
That's just the distance between.
That's just the distance. So would this be a radius?
Yeah.
Would that be a radius? Yep. Now, this would not be a radius. If I did this, I'd have to cut it in half. Now here's my deal. If I use these 2 points, I'm gonna have to deal with a fraction, which I can do, but I don't want to. So I'm gonna go ahead and find my diameter this time, because there's no fractions in it. And then I'll divide it by 2. So here we go. My distance formula. 3 minus 4 squared. Negative 6 minus 0 squared. And then my distance formula. Square root of 37. Now, that is your diameter. So your radius is half of that. Can't do anything, just equal 702. So what goes here? R squared. So you need to square this. What's root 37 squared? 37. And 2 squared is 4. There is your equation. All right, you and your partner right now try B. I don't think it's gonna have any fractions, but it's gonna be a lot easier. You guys work on B. I'll work on B, and we'll see what we come up with. And I welcome any volunteer who would like to come up with, or teams to come up with team coming up.
That's not what I got.
Got it? Bring it on up.
Because there we did the whole diameter. This doing the
Wait,
radius.
if you only did the diameter, you don't have to do any of like the division stuff, right?
So that's
Yeah,
what
you-
You only
If
solve
you did the radius
for
one,
the radius.
yeah, yeah,
Wait, are you
that will be your radius.
36
So it's.
Whoa, I got 75.
All right,
Yeah.
we finishing up and comparing your work with Erica. She's volunteered to put her stuff up there.
Why not? I thought you skipped that. Anybody should do 30, 34 over 34 over 4, making it you outside of what you did. You got the diameter, not the rock. Oh, you guys did. Oh, it's so wrong.
She got 3, 1 as her center.
Yeah.
So she is putting
You got 8.5.
x minus 3, y minus 1. And she found the radius to be the square root of 34. So when she squared it, she got 34. So her answer is right here. Very nicely done. That's what I got. Any of you get that?
I got it.
Yeah.
Does anybody have a question about where one of those numbers came from? All right, here you go.
I actually have a question. Where did the -3 and the -1 come from in the distance?
Okay, now, this is the equation. This isn't the distance.
But in the distance formula, why did you do 8 minus 3?
Okay, this, here,
Yeah.
For the radius,
It's just
she
because that's,
because the
used,
midpoint's 3.
she used this point and this point.
Oh, is that what you're supposed to do? Oh,
She
right.
was
Oh,
confused by
we
this.
used the wrong points. Okay.
Well, no, wait. Did you use that point, this point?
Yeah.
That's fine, but you have to cut it in half. Because that would be a diameter. You see what I'm saying?
Yeah.
She used these two, that was a radius.
Okay.
So that was the half. Okay. You will get the same answer if you cut yours in half. All right, friends. Let's look at the next one. And I'm not plotting these points. I'm just popping them up here. Oh, wait. M is the midpoint of AB. So that's the given. M is the midpoint of AB. N is 6'2", and B, I don't know, but A is 5'1". Okay. So take a second. Make sure you read that question carefully, 12A. Is that seem right? I mean, this is what we're trying to figure out.
Multiply by 12 minus 5.
Who has an idea, I should say? Somebody?
I'm gonna go for it.
Yeah.
Okay, so I did for the 6, I multiplied it by 2, because we know we divided it. So I did it. And then I got 12, and then I subtracted 5 and got 7 as like an x.
Perfect, so let me back up a minute. In case you didn't follow his logic, which is 100% dead on perfect, he said, I know that midpoint, I don't know what this is, but I know that midpoint involves adding these together and dividing by 2, average, and I know my answer has to be 6. So he said, the first thing I'm gonna do is multiply by 2, and then subtract 5. So I know this has to be a 7. 5 and 7 makes 12, and half of 12 is 6. Does that make sense to you? And then you did the same thing for y and that what?
I got 0. Or wait, no, I did not. Yeah. Wait, 2
1
1
plus
times
y.
3 plus Yeah.
Three.
Sorry, I'm looking in the wrong
Yeah,
spot.
that's okay. So, I'm gonna show you something here in a second, but before I do, does that make sense to you? That you can kind of find the average backwards, that you know the average, so you wanna know what are the two numbers that we average. Now, pretend for a second, I don't know what the answer is. This is right in the middle. How far is it from the beginning X to the middle X? How far is that? 1. So I'm gonna go another 1. How far is it from the original Y to the middle Y? I'm gonna go another 1. So you can do it that way too, just like that. Okay, all right, try B. You and your partner, if you hear that, I'm gonna call on somebody, give me an answer. Somebody said -13, comma, -6. Let's see if that's right. This is 7, 4. This is -3, -1. I don't know what this is. I think -13, -6 is correct. So again, the way I did, you can always set up your midpoint formula. I said, if I go from 7 to -3, that's back 10.
Yes.
So I'll go another 10. If I go from 4 to -1, that's back 5. I'll go another 5. But you can always set it up like that also. Always, always, always. Okay?
Yep.
All right, we're gonna do a couple more things and then we're gonna get done. So we're gonna be, P2 is due on Wednesday. P2 is due on Wednesday. And we're gonna start P3. Is -1 a solution of this? How would I know? What can I do to determine if -1 is a solution? Could I plug in -1? And if it's a solution, then that will be true, right? So let's see. -3/6 plus 1/6 equals -2/6. Is that true?
Yeah.
Yeah, it is. Yeah, it is. What else could you do if you wanted to? Could you solve that equation and see if you got -1 as an answer? That would be another option. Okay, number 2, are these linear equations or not? Now, what we mean by a linear equation is it's going to graph as a line, okay? It's going to be linear. So, and actually, I shouldn't say that because these only have one variable, but let's just see if we can figure it out. Do you think A is a linear equation?
Yes.
Yes, because it has an x to the first and it is solvable, right? B. Now B has an x to the first, but is it solvable? What happens when you subtract x from both sides? You get a false statement, no solution. So B is a no. A is a yes. B is a no because it doesn't make sense. What do you think about C? No, because it has a radical. And you recall from algebra 2, that's x to the 1/2. That is an x. That's x to the 1/2. So C is a no. D is a no because it doesn't have an x. It's a true statement, but it doesn't have an x. E is a no because it has an x squared. And F is a no because it has an x in the denominator. So here you go. You want to be linear? First of all, you got to make sense. Okay? Second of all, you have to have an x to the first. You cannot have an x squared. You cannot have a radical x. You cannot have a 1 over x. Linear is something like this. 5x minus 8 equals 2. That is linear. No radical, no denominators. Okay, next time I see you, is that tomorrow?
I believe so.
Next time I see you, we're gonna do a little practice quiz, because the time after that, we're gonna have a real quiz over the practice quiz.
Oh, is it P1 and P2?
P1 and P2. So I will give you a hard copy practice quiz next class. You'll go through it. The quiz you take will be just like the practice quiz.
Do we get to keep the practice quiz?
Yes. Okay?
Well, no, you're about to get
So you got some homework to do, we're gonna be working on that. You're gonna sit down and wait for the bell. We are not wild animals, we're not Pavlov's dogs. Sit down, wait for the bell, Miles. Look at the plane, I'm sorry. All right. Have a good day.
It's the lightest class right there. Well, I'm not, it's the lightest.
Ben, if you remember in 1 o'clock